Welcome back. We have a couple of examples to go through here, how to find the domain and range of a square root function. We took a look at some of the how would this happen before. We said the domain was going to be based off of this portion right here. If I look at this portion right here, I know that that portion in there has to be greater than or equal to 0. In other words, it has to be positive numbers. If there are positive numbers, I can simply set it in the inequality of greater than or equal to 0 and solve that inequality. My x values have to be greater than or equal to -3. And there's my domain. Okay, with the domain set, we can look at our range. And we said in our previous video that this number out here is going to be the starting point of our range. That's where our function is going to start. Okay, the start of our outputs. But where is it going to go from there? So y is going to get compared in some way to 2. Is it going to be less than 2? Is it going to be greater than 2? Well, now we need to look also at this number right out in front. Now in this case it's kind of hidden. It's a +1. +1 means this graph, now we haven't looked at too many of these graphs yet, but we will in a little bit. This graph is going to be a basic square root function that's going to go up like this. Okay, now because of the domain changing to a -3, it's not going to start right there at 0, 0. It's going to go back 3 spaces here, and it's going to go up like this. But not only is that going to happen, because of the 2 right here, it's going to shift up 2 units. Okay, so instead of looking like this, it's going to be shifted back 3 units and up 2 units. This is where this one's going to start, and it's going to go up like this. In other words, our y values are going to become greater than, here's where our y values are 2, and all of the y values that are coming out are above that. So our range is going to be greater than 2. The last thing that we can look at with this is what happens as x either increases or decreases. We've looked at this in polynomial functions before. In this case, because of our domain starting at -3 here, x isn't really going to decrease. There's nothing happening over here. Okay? There's nothing happening over here. So we can, however, say that as x goes to positive infinity, in other words, as x increases, okay, y also, in this case, because y's have to be greater, and we can see from our function that they're going up there, y also increases or goes to positive infinity. Let's take a look at another. This function looks a little bit different. There's a couple other pieces to this one. So let's take a look at it in much the same way, though. We're going to take a look for our domain. We're going to look at the fact that the 3x minus the 7 has to be greater than or equal to 0, and we're going to simply solve that inequality. We're going to add the 7 to both sides, and we're going to divide both sides by 3. Now, some of you are looking at this and saying, oh, great, a fraction. Well, it's a fraction. It's still our domain. Our x values have to be greater than 7/3, or 2 2/3. I'm sorry, 2 1/3. With that in mind, we can begin looking at our range. And our range, once again, starts with this 3 value over here. Okay? Y is compared to 3. But now, once again, are those y values going to be bigger than 3? Are they going to be smaller than 3? Well, let's go look at that a value. A in this case is negative. And if a is negative, that means this guy got flipped over. Instead of our normal absolute value graph where we start at 0, 0 and we go up, we've already shifted, okay? Our graph is going to start first of all, it's going to start back at, or ahead here at 7/3, or at 2 1/3, and it's going to go down, all right? And we've also said that the y values were shifted up, so the starting point's going to get shifted up as well. We'll deal with that in a minute, okay? So that's what we're dealing with here. We have to make sure we understand that our y values are now going to go down. So what's our graph going to look like eventually? And we'll talk about this a little bit more in the future. We're going to be over here at 2 1/3 and at +3, and that's going to be where our function starts, and it's going to go down from there. Maybe not quite as dramatically as was drawn just there, but that's what our domain and our range are going to do. Once again, that means as x goes to infinity, y goes to -infinity. Let's take a look at one last problem. This one is unique, and it may not look that different at first. But the one thing I want you to realize is when we set 5 minus x greater than or equal to 0, and we start solving that, we end up with a -x. And we end up having to divide or multiply both sides by a -1. And remember from inequalities, when you multiply or divide by a -1, you need to turn the sign around. And all of a sudden our domain has x values that are smaller than 5. In other words, our function, when we go to graph it, is going to start somewhere on this vertical line, and it's going to go back this way. It's going to go back to the left. Now, where on that line is it going to start? Well, our range values start with this -8. This -8. So the question is, are they going to go up from -8 or are they going to go down from -8? Since -2 here is a negative value, the range is going to go down or decrease. Okay, it's going to, oops. If our range is going to decrease, then our y values will be less than or equal to -8. So if we go look at this graph, it's going to start down here at y value of -8 and x value of +5, but from there it's going to go this way. We're running out of space down there to draw that, but we'll worry about drawing graphs in the future. Let's talk about this though now. As x goes to +infinity, x doesn't go to +infinity. X stops at 5, so this one got turned around. And x now goes to -infinity, and as x goes to -infinity, y will also, in this case, go to -infinity. Please realize the negative infinity of x and the negative infinity of y do come from different places. They're not uniquely tied together. I think we've seen that in other examples. I hope this helps us understand a little bit more about where radical functions are defined and what kind of outputs they'll give us and what they'll be looking like as we go to graph them in the next section.